So malic acid concentration, I think, is somebody or an aspect that people did not realize how crucial this is. Many people thought the lower the level, the easier and the quicker the malolactic fermentation will be. But we've realized that malic acid is a compound that actually regulates the enzyme and how it functions in wine. So, as I said, yeast, everybody goes through a whole checklist when they think about alcoholic fermentation. And that same checklist also applies to the malolactic bacteria, because the interaction and the pairing of the right yeast with the right bacteria is absolutely crucial. Nutrients, I think many people think you add the bacteria and they have to deal with whatever's in the wine matrix. If you do sequential MLF, the yeast is one of those organisms that will take up everything from the must and store it inside. And therefore, nutrient management is something that I think is becoming more and more important from a malolactic fermentation point of view. And then the other thing is, what scenario do you use? Do you use a co-inoculation? Do you use sequential inoculation? Do you use plantarum? Do you use uni? But I think the complexity of all of this is all of those factors listed are not single. They're combinations of all of those is in one matrix. So you need to understand your matrix very well when you make a decision. So measuring, I know many people in South Africa, for example, will not measure before they inoculate. And we're trying to change that mindset, that you understand what are you actually putting these poor bacteria into, that you can add the right things to make the potential success of the MLF just that much better. Okay, so the two starter cultures is the one that we all know very well, called Unococcus uni, and it has the best pH range. It can work from sparkling base wine up to the warmer climates that have very high pHs of around 4. Certain strains have been selected to be able to grow at 16% ethanol. They can survive at low temperatures, so if you leave your must during the winter, if spring arrives and everything heats up, they will start to ferment and degrade malic acid, and their sulfur tolerance is also, most of the strains can do between 50 and 60 milligrams per liter. They produce a small amount of volatile acidity or acetic acid bacteria because of the way that they metabolize glucose, and obviously the positive thing is they enhance the profile of the wine by producing esters or diacetyl. And then the new name that is really a tongue twister for all of us, we just got used to Lactobacillus plantarum and winemakers, and now the taxonomists have turned us upside down. So the new name is now called Lactobacillus plantarum, but luckily L. plantarum is still the one that we can use. So plantarum's pH tolerance is not to the lower end, so they prefer 3.3, 3.4 and upwards. Their ethanol tolerance is also a bit lower. The temperature you have to manage as well, and their sulfur tolerance. But the nice thing about them is they produce no acetic acid from sugar metabolism, so obviously your VA will not increase as much. And they show that they add aromas that is different to using uni. So, and this difference comes with a genome and the enzymes and the functioning of the enzymes under wine conditions. So obviously you have to understand, that's why I say understanding your matrix is crucial, because pH and alcohol are the two that will drive the decision that you will need to make. So the two times of inoculation, I mean, if you look at the top slide there, you can see there's about 4 or 5 different times that you can use. But I think the two that is most commonly used is called after alcoholic fermentation. In other words, alcoholic fermentation has been completed. We call that sequential inoculation. And what is nice there is obviously you can tailor make the environment for the bacteria because the alcoholic is passed, so you can manage your temperature, you can add the nutrients, you know what the alcohol will be, so you can really select the best strain for the matrix. Obviously, it's also the matrix that I think is the most or more difficult because of high alcohol and nutrient depletion. And if you have the wrong yeast that is not malolactic friendly, some of the negative compounds can obviously then be produced in the last part of alcoholic fermentation, and that will then be in the matrix that you add the bacteria to. And then the one don't want to call it new because it's definitely not new, but is co-inoculation or simultaneous inoculation is where you add the bacteria with the yeast in a grape must. So obviously there's no alcohol and the nutrients that the must provides is available to the bacteria. So obviously it's a more friendly environment. And also this figure on the right-hand side bottom just shows you that the genetic expression of the bacteria comes out much stronger in the grape juice because everything is available. The yeast hasn't used up all the precursors for aroma. And then if you go to 40% alcoholic where you inoculate 60% or sequential, you will see that the potential diverse impact of the bacteria becomes less because the yeast has used most of the compounds during alcoholic fermentation. So obviously that gives us a lot of scope for thinking about MLF in a different way. So this is just to show you the typical descriptors that is associated with MLF and no MLF. And the top one is just to show you if you have the same wine, same matrix, and you do one co-inoculation and one sequential. For example, this was wine done in South Africa with Enococcus uni. You can see that the sequential is driven by the buttery character. So buttery is one of the compounds that is very prominent in sequential inoculation because of the way that the metabolic pathway works, but I think Alda will say something about that. And on the co-inoculation side, you can see it's much more berry-driven, fruit-driven. So co-inoculation, and then there you can see there's a subtle buttery here at the bottom. So obviously, by just changing your inoculation time, you will end up with a different aroma profile in your wine. The bottom one was Chardonnay from an article where they did MLF in tank and barrel. And I'm not sure here in Spain what the common practice is, but in South Africa for Chardonnay, many of the fermentations are done in barrel. And you can see if you do the MLF in tank, it will be a much fruit, floral-driven wine. And then if you do the MLF in barrel, you will add the complexity of butter, vanilla, oak, and caramel. So this is just two choices that you have to make as winemaker. So I think one of the most important thing is the amount of bacteria that's on the market has increased since I started working when there was about 3. And I think there's about 30 to 40 different cultures now. So obviously the choices that you have to know what you want to achieve because every strain is different, every matrix is different, every end product that you want to achieve will be different. So obviously choosing the right strain for the right reasons, for the right matrix is one of the most important things that will determine the success of MLF. As I say, the one thing that came out now in the last 2 to 3 years is the impact of lactic acid on the growth of MLF. And this obviously in cooler climate regions where your malic acid concentration is normally can be anything between 4 and 8 grams per liter, the amount of lactic acid that will be produced will increase. So you can see in this first one, where 0 lactic acid was available, MLF took about 33 days. If you have 1.5 grams of lactic acid, you can see that you have a decrease in cell numbers. So the cell numbers are the triangles to below 6 million or million cells that we need. And then if you have 3 grams per liter, you can see that the duration, it never finished. It was stuck. So that's something that you have to keep in the back of your mind. You should ask your provider of your bacteria what is the resistance of their strains to lactic acid, because there are strain differences. So some will already at 1.5 grams per liter be inhibited, and others at 3. So if you work in a matrix that has very high malic acid concentrations, you should definitely think about this. So adding nutrients, as I say, is also something that is really important. So this is just to show you that by adding nutrients, they reduced the time of the MLF, and we also know that Plantarum has a lower demand from an amino acid point of view than Unococcus uni. So if you have a block of vineyards and you know every year that block struggles, maybe try something different, be innovative, and look at Plantarum as a potential solution to your problem. So this is just to show yeast-bacteria combinations. We had 4 different yeasts, 2 different bacteria, and you can see there's only one combination that had finished MLF. So this is why the importance is you have to think about MLF before you start your alcoholic fermentation, because if you add the wrong yeast, there's no chance that your bacteria will manage this. So as I say, pH and ethanol is 2 crucial factors that you as winemakers have control over. You can decide what your pH should be of your fermentation. You can make acid adjustments, or you can harvest to make sure that the ethanol range that you are aiming for is there. So we had 2 strains. We did it in Riesling in Germany and Chardonnay in South Africa. And you can see that the percentage is the percentage of malic acid that was degraded. So low pH with moderate alcohol is not a problem. You can see that almost all the malic acid was degraded. And this is just to show you the relative impact on aroma. So obviously this is the control that just had the yeast, and there's a 3.5-fold increase in the amount of esters in these wines. Then if you go to low pH and high alcohol, it's the most difficult matrix for the bacteria to actually cope with. So there it's really important. But what is also important, you can see the impact of the condition. The cell numbers reduced to around 10 to the 3, which is obviously too low. But even if there's only a partial part of malolactic fermentation that happens, you can see that there was an impact on the total amount of ester. So even if you have partial MLF, you will have an impact from an aroma perspective. So, and I think that is important. And sometimes you only want to do maybe a part of your wine with MLF and blend it back. So, or you have a condition where you just want to reduce the amount of acidity by a portion. You can obviously then, with that portion that you do with the MLF, you will have an impact. So, then this was a study I think that is interesting, just to show over different seasons that in a very difficult matrix. You can see you ended up with, or started with 8 grams per liter of malic acid, which is relatively harsh. It's only the co-inoculated wine, which is the squares. This thing is very slow to react, but yeah, there you can see that one, this one, and the last one. It's only the co-inoculation that actually managed to finish MLF. So if you have really difficult conditions, it's something that you can consider as an option. So from that study, they also wanted to see what was the impact on the aroma, and co-inoculation had the most esters. So co-inoculation drives the fruit characters of the wine, and the sequential had the most diacetyl, and those compounds translated into what was perceived from a sensory perspective. So for the Chardonnay, you can see co-inoculation, fruity, fresh, floral, and the sequential, you can see there much more buttery character compared to the rest. So by switching your mode of inoculation is important. Okay, so I think the aspect that is currently being driven, I think there's quite a few talks at this conference about non-Saccharomyces. So non-Saccharomyces and MLF is also something that is being investigated a lot, and we've seen now that certain of your non-Saccharomyces is definitely more friendly towards MLF because of manoproteins that bind some of the toxic compounds. They produce less sulfur, and sulfur we all know is an inhibitor of MLF. And then on the other side, you have some of the other non-Saccharomyces that produces sulfur or can produce acetic acid, but can also remove malic acid, so they can help the bacteria if the levels are too low. So yeah, so you must make sure if you are using non-Saccharomyces that you understand the matrix and the microorganisms that will be in that matrix, and make sure that all of them are actually helping each other in the fermentation. So yeah, so obviously oxygen is something we've seen. If you have oxygen and nitrogen, that there's a genetic reaction. So the bacteria actually activates its genome and genes to assist it. So the stress responses, if you have oxygen in the wine, is upregulated. So management of oxygen, and Alda will touch on microoxygenation. So the question you have to ask yourself, you've got a whole toolkit. What in this toolkit do I actually want to use? Do you have a need for speed? Is it just you want to get malic to lactic as quickly as possible, stabilize your wine because it needs to get into the market early? Then choose a bacteria that can do that. Do you want to use the diversity that's available? You want to use Unococcus uni and Plantarum as a combination because they have different characteristics that will translate into different aroma compounds. So the question is, you've got all these options, just use them in a way that you will actually enhance the process and the growth of the bacteria. So, muchas gracias. That's my part.